Now this is part 2 of the solutions for project 1, and we will now be working through the free response questions. All right, now the free response questions, it's important that you show all your work, show all the steps, because there is partial credit for the steps. All right, if you just write the final answer, you will only get a fraction of the point assigned for the whole question. All right, so wherever it makes sense, just show as much work as you can. Now the first question here says, use the graph of f to determine the following and use the interval notation. So basically we are testing you on whether you can read the graph of a function and whether you are able to interpret it. So here's the function given to us. The first question says, what is the domain of f? So as we see over here in the graph, there are arrows, right? There are arrows going at both ends, on the left-hand side, on the right-hand side. Therefore, this would mean that this is a continuous graph. This is a continuous graph. It doesn't have any breaks as far as the domain is concerned. It keeps going and going as far as one can to the left on the negative side, and keeps going and going as far as we can get on the positive side. So therefore, that means that the domain would be what does domain represent? All the x values that can be input into a function, which will produce a real number for a y value, right? That's the definition of a domain. So let me pull up my pen here. So for the domain, this is what I'm going to write in interval notation. Put a round bracket. Now, whenever you have negative infinity or positive infinity, you must surround it with round brackets, all right? Because negative infinity and positive infinity are not really numbers. It just tells us that we can keep going as far as we can on either end. So we got the domain of f, negative infinity comma positive infinity, the range of f. That means what are the possible y values that can be obtained from it. So here we see, by looking at the graph, the lowest point, all right, for the range, it's the y values, right? So let's look on the y-axis. On the positive y-axis, the graph keeps going and going and going, all right, as far as it can stretch upwards. However, on the negative y-axis, the graph goes up to -4, all right, let me get a different color, up to -4, and then it starts increasing. So the lowest point that the graph reaches is y equals -4, right? So that's the smallest value that y can take. So the way we write the range of f, or represent the range of f, is put a square bracket, because -4 is included in the range. So -4, but after that, once it starts rising, you see this arrow means that it's going to go as far as it can on the positive, along the positive y-axis. So -4, comma, infinity, and again, because we are using infinity, use a round bracket around it. The next question says the x-intercepts. X-intercepts, where the graph crosses the x-axis, right? So you have to give the coordinates of the x-intercept. So we see that this graph crosses the x-axis at 2 points, one here and the other over here. So the coordinates of this point, and remember at the x-axis, the y coordinate is, the y value is always 0. So I'm going to write it as 1, 0. And on this side, for this intercept, it's 7, 0. So those are the x-intercepts. So 1, 0. So here, these are the coordinates. It's an ordered pair. It's not an interval like for the range and domain. So x-intercepts 1, 0 and 7, 0. Those are the x-intercepts. What about the y-intercepts? Where does it cross the y-axis? At this point here. And at the y-axis, a point on the y-axis always has 0 for the x value, x coordinate. So 0, 4. So for the y-intercept, we are going to write 0, 4. Right? Intervals on which f is increasing. So when it says intervals, that means on the intervals on the x-axis. All right? Intervals on the x-axis. So let's see, f is increasing. Where is f increasing? Where is the function increasing? It increases from this point here and then goes up, right? From x equals 4 all the way up to infinity, right? So this is the vertex of this u part of the graph, and the lowest point is at 4, and after that it keeps increasing. So we are going to say the intervals on which f is increasing is 4, infinity. Intervals on which f is decreasing, let's look at that. F is decreasing from here all the way up to here, right? Up to 4. So we are going to say, let's see along the x-axis what the interval is. So from here, this is 0, right? X is 0 here and goes all the way to positive 4. All right? It decreases in that interval. So 0, positive 4. Values of x for which f of x is less or equal to 0. Right? So what does that mean? Values of x for which f of x is less or equal to 0. That means values of x where the y value is 0 or less than 0. So let's look at the graph here. We're looking for the y values. Remember, f of x and y are used interchangeably. So y value 0 would be everything, okay? All these values are negative values for y, right? Anything below 1 and 7. So what we are going to write here is 1, 7. Actually, let's put round brackets, 1, 7. The numbers at which f has a relative maximum. Does this graph has a relative maximum? No. All right. So it doesn't have a relative maximum. It has a relative minimum. So we are going to write here not applicable. It has a relative minimum, but it doesn't have a relative maxima. However, let me tell you, if the question said what is the relative minima or minimum, the numbers at which f has a relative minimum, then it would be x equal to 4. All right, x equal to 4, that's where the minimum is located. The minima is located. So you were going to say x equals 4, at x equals 4. And what would the relative minima be? Relative minimum or minima would be, that's the y value we are looking for, it would be negative 4. All right, this value here. So it would be y equals negative 4. F of negative 2, again, that says what is the value of y when x is negative 2. So let's go up. At x equals negative 2, y is 4, right? This point is negative 2 comma 4. So f of negative 2 is going to be 4. The values for which f of x equal to 0. So the values for which f of x equal to 0, that means values for which y equal to 0. So let's see. Where is y equal to 0? At x equal to 1 and x equal to 7. So you're going to say at x equal to 1 and x equal to 7. Is f even, odd, or neither? All right. Now, this is a graph, so we cannot show our work. So this is not applicable. We cannot show our work, but we have to look at the graph and we see that it's neither. It's not a reflection across any of the axes. All right. Therefore, it's neither even nor odd. So we are going to say neither. Right? I just need to go and correct something on question G here. It says values of x for which y is less or equal to 0. Now what, I had misstated this. 1 comma 7 is correct, all right, because y values are 0 at the x-intercept when x is 1 and x is 7. However, the surroundings, the brackets should not be round brackets here. So I'm going to go and erase this and write the interval as 1 comma 7 surrounded by square brackets because 0 is included. All right, so 0 is included. It's inclusive. Therefore, we surround the interval 1 comma 7 with square brackets. I just wanted to correct that before I go to the next question. Let's work on question 2 now. It says find and simplify the difference quotient f of x plus h minus f of x divided by h. So the function here given to us is f of x equals x squared plus 6x plus 4. So we first have to do an evaluation with f of x plus h. All right, so I'm going to do that on the side and then I'm going to plug it into this difference quotient. So f of x plus h, let me do that on the side. F of x plus h means I'm going to replace all the x values in this function with x plus h and simplify it. So x squared would be then x plus h whole squared plus 6 times x plus h and then plus 4. And let's now start simplifying this. X plus h whole squared, I'm going to apply the a plus b whole squared formula to expand this. So I'll get x squared plus 2xh plus h squared. And then for 6 times x plus h, we have to distribute the 6 to x and h. So plus 6x plus 6h plus 4, right? And let's see what we can combine here. Can we combine anything? Not really. All right, so this whole thing is going to stay as is, which we are going to plug in for f of x plus h in the difference quotient form. All right, so now I'm going to, so let me write the form here again, f of x plus h. And I always show your work for the free response questions, all right, because every step has points assigned to it. So f of x plus h minus f of x divided by h. So I'm going to replace the f of x plus h with what I found here. So it's going to be equal to x squared plus 2x times h plus h squared plus 6x plus 6h plus 4, and then there'll be a minus sign. This minus sign comes here, and then f of x is this expression, all right, this polynomial. So we are going to just write it as is. It says f of x, so I'm going to write that, surround it with another set of brackets, x squared plus 6x plus 4, and divide the whole thing with h, right? So let's go on. Now we have to take the brackets off and simplify. So the first bracket stays, the terms stay as is, but I'm going to take off the brackets. X squared plus 2xh plus h squared plus 6x plus 6h plus 4. Now there's a minus in between, so when I take off the brackets of x squared plus 6x plus 4, all these signs will change, right? Yeah, because we are multiplying everything by minus 1. So it's going to be minus x squared minus 6x minus 4. Minus 4 divided by h. So now let's see what we can, or how we can simplify this. We see x squared and x squared, they subtract, right? X squared minus x squared is 0. So we got rid of the x squared. Then we have 2xh. Is there any other term with xh in it? No, right? So 2xh stays as is. H squared. Is there any other term here with h squared in it? No. So h squared stays as is. Is there any term with 6x in it? So we have 6x here, right? So plus 6x minus 6x becomes a 0. So we can remove that. And then 6 plus 6h. Do we have any other term with h in it? No. So that stays plus 6h. And then the plus 4 and this minus 4 0 out. So I'm going to cancel those out, and now we have 2xh plus h squared plus 6h divided by h. Now the h is the common denominator, so you have to distribute it to all the terms at the top. You have to distribute it to all the terms on top and simplify. So 2xh divided by h plus h squared divided by h plus 6h divided by h divide. So we have 2x, h squared and h is plus h, and 6h and divided by h is plus 6. Okay, and that's the final answer for this problem. Now, question number 4 is on graphing. And as we see over here, h of x equals negative absolute value of x minus 7 plus 2. So we see it has, it involves transformation of the basic absolute value function graph. All right. And it's a combination of transformations. All right. It includes several transformations in one function. All right, so let's start with writing the base function. We see there's an absolute value in the function, so the base function, and let's write that, f of x equals absolute value of x. That's the basic absolute value function, and then we have added transformations to it as we see in this function, and we call it h of x. Now, the complete transformed function, the complete transformed form of the function, let me write that in generic form, is a times, sorry, not it shouldn't be brackets, it should be the absolute value sign. So absolute value, hold on, I'm just trying to work this out. X minus h plus k. All right, that's the general form of a transformation, which includes a vertical shifting, a horizontal shifting, as well as vertical stretching or shrinking. All right, now we have to find the value of k from this function given to us, the value of h again from here, and the value of a. All right, so I'm going to take this function h of x and put it in this form so that we can align the a and h and k's and pick those values. So let's do that. H of x equals, there's a minus, and when we don't see a number next to the minus, that means it's a -1, right? And then the absolute value notation, x minus, and then there's a 7. So this x is aligned, this minus is aligned, and we have a 1. No, not a 1. I'm sorry, it's 7, right? Sorry, we have 7 for h. So and then the absolute value, and then plus, that matches the form as well, and 2. All right, so we see k has a value of +2. So k, let's pick the values now. K is +2. If it's positive, then it shifts up the y-axis by 2 units. By 2 units. H is a +7. All right, h is +7, so it shifts right. Horizontal shifting is either left or right. If h is positive, it shifts to the right. If h is negative, it shifts h units to the left. So let's write that, shifts. Now I encourage you to write out the transformation as I am doing here, because you can get partial credit even if your graph is not absolutely right. If you write it down and it's correct, how you've interpreted the shifting or the transformation from the function, then you will get partial credit. All right, so shifts right by 7 units. And then we have a, right? Now, there are 2 things to mind about a. If a is negative, then, or if a is negative, then graph opens down. In other words, it's a reflection of the base graph across the x-axis, but I'll just write opens down. And if a is a value, in this case a is 1, right? A is a value equal to or greater than 1. So if it's greater or equal to 1, then it vertically stretches. All right, it's stretched. It's vertically stretched. However, here, let me write this and explain. If A is 1, as it is in this case, or the absolute value of A is 1, then it's the same as the base graph. All right, there's, as far as vertical stretching is concerned. All right, so the base graph is going to be something like this, right? That's how the base graph would be. It would have its vertex at 0, 0. Now we transform this because of k, the value of k, we have to shift up by 2 units. So that means, I'm going to use a different color. It's going to shift up by 2 units and then shifts right by 7 units. So I'm going to go 1, 2, 3, 4, 5, 6, 7. So that's where the vertex is going to be for the transformed graph. And then because it's there's a minus associated with A, it's going to flip, right? It's going to flip down. The graph opens down. And so we are going to just make it like this. All right. So this is how, this red graph is how the transformed graph is going to look like. All right. Now, question number 5 is on combination of functions. We have been given two functions, f of x equals 5x plus 1 divided by x squared minus 9, and g of x is equal to 4x minus 2 divided by x squared minus 9. All right, so we have to perform these operations, all right, the algebra, by combining these two functions and come up with a new function. All right, the result will be a new function, and then we also have to provide the domain of the new function. The first one is f plus g. All we do is add up the two functions. Right now, f plus g is the same as writing f of x plus g of x. So f of x is 5x plus 1 divided by x squared minus 9, plus g of x is 4x minus 2 divided by x squared minus 9. We have a common denominator, makes things easy for us. So we just put the common denominator below and add up these two, the numerator of the two functions. So 5x plus 1 plus 4x minus 2. So now let's combine. We have 5x plus 4x is 9x, and plus 1 minus 2 is minus 1 divided by x squared minus 9. All right, so this is all that we can do, all right, to simplify this. Now we have to find the domain of this function. All right, now because this is a rational function, the new function is a rational function, therefore remember, when there's a denominator and there's an x in the denominator, we cannot have the denominator become 0, right? So x should not take any value that will make x squared minus 9 equal to 0. So the way we find the domain to exclude for x in this new function is, may take on the side, just take x squared minus 9, make it equal to 0 and solve for x to find what value of x would make x squared minus 9 equal to 0. So we have x squared equals, and move the 9 over to the other side. So we have x squared equals 9. So take the square root of both sides, plus minus on the other side. So we'll end up with x equals plus minus 3. Or you can also solve this by because this is a difference of squares, you can also do this. X squared minus 9 is the same as factor it out, x plus 3 and x minus 3, and then make it equal to 0. So we have x equals negative 3 and x equals positive 3. Whichever way you are comfortable with, just solve for x. So we got x is plus and minus 3, two values. So now we have to exclude these two values when listing the domain. All right, so the way it goes is x can take any value from negative infinity to positive infinity except negative 3 and positive 3. So at negative 3, we have to put a break. And then we go along, and then from at positive 3, again, there will be a break in the domain, and then it will continue. So the way you write it is negative infinity. You can start from negative infinity, go all the way to minus 3 and put a round bracket because negative 3 is not included in the domain. And then union, you can start again from immediately after negative 3 and go all the way to positive 3. All right, and then stop there. You can go as close as you can to positive 3, but not 3. All right. And then another union from 3, you can keep going all the way to infinity. So that's how we write the domain. We determine the domain because there's a denominator in it. We have to find values of x which will make the denominator equal to 0. And let me just mark this separately. This is our side work. And then we put it in this notation, in the interval notation, excluding the values of x that will make the denominator equal to 0. All right. The next one is f minus g. Again, same process, except that you have to subtract here. All right. So I'm going to have 5x plus 1 divided by x squared minus 9 minus, what was it, 4x minus 2 divided by x squared minus 9. Again, common denominator, x squared minus 9. So all we do is, and first let me just use brackets because this minus is going to make a difference because it needs to be distributed to 4x minus 2. All right, whenever convenient, make it, or whenever possible, make it a habit to use brackets when you're working these problems, especially in algebra. All right, so now I'm going to take up the bracket. So we have 5x plus 1 minus 4x. This minus has to be distributed to both terms. See, the reason I stressed on the brackets is if you didn't put the brackets, the general tendency, and it's a natural tendency, would be to distribute the minus to 4x and forget about the minus 2. All right, this minus needs to be distributed to the minus 2 also. So if we have the brackets around 4x minus 2, then it's easier for us to remember, okay, we have to distribute the minus sign to everything within the brackets. All right, so that's the reason I keep stressing on using brackets. All right, so I'm going to write it as minus 4x and plus 2 divided by x squared minus 9. And we will get an answer of 5x minus 4x is x plus 3 divided by x squared minus 9. All right, now we could simplify this, all right, further and have it as x plus 3. Remember, x squared minus 9 can be factored as x plus 3 times x minus 3, and then cancel out the x plus 3 and get x minus 3. 1 divided by x minus 3 is in simplified form. All right. However, when you figure out the domain, all right, when you write the domain, you have to look at this denominator, x squared minus 9, and not just x minus 3, all right? So same process as we worked in the addition before. Just take your x squared minus 9 make it equal to 0. We will have x equals plus minus 3. So in the domain, please, when you're determining the domain, use x squared minus 9 and not x minus 3. So the domain is going to be the same as the previous one, minus infinity to minus 3, then union minus 3 comma positive 3, and then union 3 comma infinity. All right, let's do the next one, which is a multiplication, f times g. So here, what do? We have 5x plus 1 divided by x squared minus 9 times 4x minus 2 times x squared minus 9. So we have 5x plus 1 times 4x minus 2 divided by this is x squared, all right? Here, let me use brackets. We have x squared minus 9 squared, all right? So foil the numerator. Once we foil it, we will get 20x squared minus 6x minus 2 for the numerator, all right? And for the denominator, we will get x to the 4th minus 18x squared plus 81. Okay, so that is we get another rational function after doing the multiplication, which is a new function obtained after combining f and g using the algebra of multiplication. Now, to figure out what the domain would be, it's going to be the same, all right? X squared minus 9. You don't need to solve using this expanded form. We know that the factored form is x squared minus 9. X squared minus 9 is the factored form, basically x squared minus 9 squared, of course, all right? So we've already solved for x. Okay, x squared minus 9 equals 0, all right? Then, so x will be plus minus 3. So use the same thing here. Minus infinity, comma, negative 3 union, negative 3, comma, 3 union, 3, comma, infinity. All right. Going on to the last one, which involves division. Let's do that. We have 5x plus 1 divided by x squared minus 9 divided by 4x minus 2 divided by x squared minus 9. So what do we do here? In division, in algebraic division, or any division, even in arithmetic division, we keep the numerator side, which is the one on the left hand side of the division sign, the same. We change the division into a multiplication and we flip the numerator and denominator of the second fraction, correct? So x squared minus 9 will go to the numerator and 4x minus 2 is going to go to the denominator. Let's put brackets around this. X squared minus 9, x squared minus 9 divide. So the new function is going to be 5x plus 1 divided by 4x minus 2. This is the new function. However, to find the domain, all right, to find the domain of the new function, it'll be take your 4x minus 2, make it equal to 0. So we will have 4x equal to 2. Therefore, x is 1/2, right? 2 divided by 4, x is 1/2. So we have to exclude 1/2 from the domain of this new function. So let's do that. It's going to be minus infinity, comma 1/2, and then union 1/2, comma positive infinity. All right.